graders, it's Mrs. Lillis. We are in the very last lesson of Unit 7. So this is 713, and it is identifying and visualizing patterns. So today we're going to be also continuing with what you've been doing this week, but we're predicting something which is really cool. It's actually something in real life. So it's something called Old Faithful. Now, Old Faithful can be found at Yellowstone National Park. I'm just going to read you this little blurb here, and then I'm going to show you a really cool video before we fill out our X and Y chart. So it says Old Faithful, one of the 200 geysers found in Yellowstone National Park, is one of nature's most impressive sights. Old Faithful is not the largest or tallest geyser in Yellowstone, but it is the most dependable. It erupts at predictable intervals. If you time the length of one eruption, you can predict how long you will have to wait until the next eruption. The formula that describes Old Faithful's eruption pattern is, okay, and it tells you here. So we're going to be working with that in a minute, but I just want to show you. I'll put this link on the slide so you can see. But I'll have this so you can click on it if you want to look at it. But here it is. And this is the Yellowstone National Park website. And you can see a video. It says it's an Old Faithful live webcam. I'm not sure if it's exactly live, but you can see that it's starting. And then I'm just going to skip a little. See that? Isn't that cool? So imagine being in person, being able to see that. And you can see, I think at the end they show people like waiting. It's loading and loading, but you can kind of get an idea for it. So if you look on your own, I think you would really like to see this. You can click on the video. You can see how they have it set up where people can watch. So that's really neat. Wow. There it is. Okay, so I'm going to close out this window, but I really think you're going to enjoy checking this out. So what's cool that we're doing today is we're actually working with data that comes from nature, which is kind of neat how we're tying into like what we've been doing in Stokes and science. So here is the X and Y chart we're going to work with today. And it says use the formula to complete the table. So this was the formula they just told us. So meaning when you're standing there at Old Faithful, it's not squirting up water all the time. It's just coming at different intervals. So we have to follow that says the wait time. So you have to figure it. You're waiting in between each time it erupts is 10 times the length of the last eruption in minutes plus 30 minutes. So you're doing a little bit of waiting if you're there in person. So they did the first one for us. If the first one, remember, first column represents X. So you can see it goes 1, 2, 3, 4, 5, 6, all the way down. And then the wait time to the next eruption in minutes, it started with 40. So that means 1, now look at the formula. 1 times 10, right, is 10 plus 30. That's where they got the 40. 10 plus 30, 40. The next one is 2. Now do you think? 2 times 10 is 20, and then add the 30. So the next one would be 50. Okay, next one is 3. So 3 times 10 is 30, and then you're adding 30 to that. That would be 60. The next one, 4. 4 times 10 is 40, plus 30 is 70. I'm not paying attention. Next one, 5 times 10 is 50. And 50 plus 30 equals 80. Okay, next one, 6. 6 times 10 is 60. Plus 30 equals 90. Okay, next one's a little tricky. So we have 2.5. So think, what's 2.5 times 10? Okay, so you add that. That would be 25. And then you add 30 to 25, and your answer would be 55. And this last one, it's starting, you notice the numbers are starting to go down. So right now, we're noticing that the length in minutes is is getting shorter. So we kind of have to work backwards. So what I would do is do 35 and you think minus 30. Okay, so that would be 5. Okay, and then what would that be if you did divided by 10, 1/2? Okay, well, that didn't fit so well. So now, if I were to fill in my coordinate points, remember, you just copy the x and the y. 2, 50. Oh, I got to make these a little bigger. 3, 60. 4, 70. 5, 80. 6, 90. 2.5. I'm going to just write 2.5, 55. And I'm going to do 0.5, 35. Okay, so these look a little, I'm going to just drag these little boxes to make it look a little bigger because I think it's hard for you to see. That's better. Just give me a sec here. And then you can see we just did number 2 where it says write each pair of values from the table as an ordered pair. So these are ordered pairs. And the first one's done for us. Yes. Now number 3 says plot each point on the grid. Use a straight edge to connect the points. Well, we have a little trouble on the computer doing that, but if you just plot the points, that's fine. Okay. Maybe I have to make that one a little bigger. Okay, can we see these? That's much better, right? So now I'm going to drag my points and plot them. So the first one was 1, 40. So I'm going to go over 1 and up 40. Remember, it's not going to be perfect as long as it's close enough. Next one, over, it's 250. So go over 2, up 50. And do you see the whole reason why we're thinking about Old Faithful is it's something that's actually predictable in nature. So we're going to go over 40, up 70. So, if you're a scientist and you want to study Old Faithful, or you're even a tourist and you want to go visit Old Faithful, it's kind of neat what happened here? You can actually go there, and I'm sure they have some sort of schedule, like next eruption is this time. Over 40, up 70. It doesn't seem to be working there. It's not showing up. Let's try the next one. Over 5, up 80. I'm having a little bad luck with this, but I think you get the gist. Over 6, up 90. Okay, well, for some reason, I don't know what happened to my dots, but as you've been working all week, I think you'll realize that your numbers are going like this. So your dots should be going like that. Okay, and that's pretty cool how you can see the prediction of when it's going to erupt next. So the next task you have to do after this is you're going to work on this exit slip. Okay, and it says use the given rules to complete each column of the table. So remember, you're following the rule. Rule is adding 1, okay, going down. And for y, it says adding 6. So you're adding 6 going down. Now, when they ask you for a rule, remember your rule is how do you get from the in to the out? Or how do you get from the x to the y? That was like the hint. The in numbers to the corresponding out numbers. How do you get from 0 to 5? How do you get from 1 to 11? That's what you have to really think about. Okay, so that's your task. You're going to do the coordinate points here. You're going to figure out the rule and plot your dots. Okay, and then you have one final question here, A and B. Use the graph to answer the questions below. So you're going to have to look back at your graph. All right, so good luck. Okay, working on your exit slip. If you want, check out this video of Yellowstone. It's really cool. I'll post that in the slides. Okay, and this is the last lesson of our book. And next week, we're going to be starting some different things, kind of reviewing what we've been doing lately. Okay, good luck.